Hey everyone, we are going to derive the quadratic formula, and I'd like you to grab a piece of paper if you don't have one already and attempt to follow along. Stop where you need to, replay it where you need to. It's actually a really beautiful derivation or proof, and it kind of gives some reasoning behind our completing the square that we've been doing to solve, and it allows us to have a formula that we can use for standard form quadratic equations. So I am going to take my standard form of a quadratic equation, and that's f of x equals ax squared plus bx plus c. And let's follow along with our standard way to solve this. So I'm going to set it equal to 0. So ax squared plus bx plus c is all equal to 0. And we'll do the same steps we always do. Constants on one side, variables on the other. So we have negative c equals ax squared plus bx. Now, before we made this perfect square trinomial, we always have to factor out a, and in this case, it's actually an a. So we're going to factor out an a, so x squared. Remember, factoring is really like just dividing out. So I'll have b over a to the x. And here's where I'm going to leave a space for what I'm going to put in, and a space for over here. So here's where we're going to deal a lot with fractions, so just follow along the best you can. We are going to take b divided by a, and we are going to divide it by 2, and then square it. So I'll do that over on the side. So we have b over a divided by 2. So divided by 2 is actually like multiplying by 1/2. So we have b over 2a, that's half of b, and then we're going to square it. So we're going to square the numerator and square the denominator. So we end up with b squared over 4a squared. So we'll add that here. B squared over 4a squared. All right, now remember we have to add something over here to the left, but it's multiplied by this a, right? So we're going to take b squared over 4a squared and multiply it by an a to get this out here. So I'm going to write it small over here. So b squared over 4a squared times a. We'll notice that this a and one of these a's will cancel out. So we're actually only adding b squared over 4a to the other side. All right, so here, let's do some more simplifying. We'll have equals a, and then let's figure out what's going to go in here. Well, remember it's always x plus or minus, depending upon what the sign is here, whatever this was before we squared it. And we can say that here's where it is before we squared it. So x plus b over 2a squared. Over here on this side, let's add these things together. So b squared over 4a, and we can do that on the side over here, b squared over 4a minus, well, I want the c over 1 to become a 4a. So we just multiply it up top. 4ac over 4a, well, the 4's would cancel, the a's would cancel, and I'd really be left with c. So that's what's going to be over here on this side. b squared minus 4ac. And we'll put it all over one fraction. There we go. So the numerators were added and over the same common denominator. All right, things are looking messy, but hopefully you're following along. Now our next step to continue to solve would be to divide everything by a. That would be our next step. So let's cross that out. And let's see, dividing by a is going to have us do something a little more interesting on this side. So dividing by a is really multiplying by 1 over a. So here I'm going to have the same numerator, b squared minus 4ac, but the denominator is going to be 4a squared. I now have 2 a's in the denominator. And over here we have x plus b over 2a all squared. All right, here we are now, and the next step we do would be to take the square roots. So that's something that we've been doing all along. So we'll take the square root of that side. And let's write that this is now plus or minus the square root. Actually, what I'm going to do is separate it as I write it. The square root, remember we can separate the radical with the fraction. And then that's going to be equal to x plus b over 2a. So we took the square root of each side. This side ends up being plus or minus, and this is the same. I just split the fraction. So let's scroll down a little bit and think about a couple different things that need to happen. We need to simplify this side, and we also need to bring this over. I'm going to simplify this side first. So plus or minus, well, since this has a subtraction sign, I can't take the square root of any of the pieces inside. So that portion is going to stay. And if anyone happens to know the quadratic formula already from last year, you can kind of see it starting to take form. And our denominator, since it's the square root of things all multiplied inside, I can take the square root of each piece. So the square root of 4 is 2, and the square root of a squared is a. And that's equal to x plus b over 2a. That hasn't changed much over there. The last step would be to subtract this term over. So negative b over 2a plus or minus square root of b squared minus 4ac. It's also over 2a. That's pretty much our quadratic formula, but it's never written like that. It's always written as a singular fraction. And we talk a lot about making and turning this term into a singular fraction. So if we bring that over to the side and we make it over one denominator, a 2a, that's the denominator of both, we'll have negative b plus or minus the square root of b squared minus 4ac, that's an a, all over 2a. I'm going to make that a little more clear, ac. And for those of you that, like I said, know the quadratic formula, this is what you've been told. You've been told it equals this, and here is why. The completing the square that we've been doing from the beginning. Actually, if you do it out with all the variables intact, you can see that the same steps we've been following are still here in variable form. So this is the quadratic formula. So the quadratic formula did not just appear out of nowhere. Someone didn't just decide to make it up and pull the a, the b, and the c out of a standard form equation. They formulated it and solved for x in a general form so that we can use it all the time. And when we get down to this point and we say, okay, well, x equals this, what does that really mean? Well, these are our zeros. And we can use this formula anytime we're given a standard form equation to find the zeros. And this will be your ticket. You'll hand this worked out derivation in. So everything we have here, you'll hand in with your name on it as proof that you had to suffer through watching me derive it, and that'll be your ticket to be able to use it on the assessment. Now is your turn to answer a couple questions below in the formative and have it ready for tomorrow.